standard design. This is angle. Okay. The angle can be like we see here is L. You may have T. Maybe you have U channel. You may have Z. So these are all riveted to the skin. Yeah. Typical. This is typical structure cons aircraft construction. Okay. So those angle could be, so the angle that you see, either we call it stringer or stiffener. It carry the axial load from the skin. Okay. So it's either riveted. So this is riveted or bonded. Riveted or bonded. Bonded mean that it has adhesive or glue. Okay, for example, if we have the L here, okay, so it is bonded by adhesive here. So this is bonded. Third, using adhesive. If you are having composite structure, the construction is the same, but you have laminate of carbon, okay, layers and layers of carbon. They also have angle, which also make from layers and layers of carbon. And obviously, this is adhesive. Some, they also install fastener. It's not standard rivet. They will use high lock because you don't have to, okay, you don't have to compress the head. So they use high lock. Special fastener. So this is typical. If you have seen, if you are designing a butt head frame, so butt head frame typically okay, we have angle, attach your skin, riveted. They have web, metal, sheet metal web, and we have angle. and then reverts. So this typically frame. This is frame, which make up the so we call this as web skin. Okay, call this as frame web skin, and the rest is still angle. So this is all angle. So this is typical. So you cannot run away from having two features, which is skin and angle. For the large bar head, for example, pressure bar head, it will be very large web. So we have skin fuselage, and then you have round bar head, closed bar head. If you cut the section off, you will see similar design. So this is web skin, continuous. We have the skin, and we have the angle. Okay. And this is continuous to somewhere yeah. So we still have skin, fuselage skin, and we have okay, this is all riveted. So here is the head web skin. Okay. And the rest still they are all these are angles. This is all angles. You can see this in your assignment that you have a problem on the flange of this web of the frame and also on the skin itself. So that is your assignment. We have damage on angle, okay, horizontal, and damage on the skin. So that is what you have for your assignment. Okay. Any questions so far? Anyone with any questions? Okay, now let's look at, we have done the analysis. We have the angle. Okay, angle which is reverted to the skin. And we have this angle damage, and then we have cut off angle here. You remove, then you install a doubler. Install doubler. So 1, 2. Remember again here the cut. There was a question by our friend earlier. You cut here in the middle. Cut here in the middle. Okay. Importantly, the edge distance between this fastener to this. Okay. This to this. This to this. When you do the cut, we keep it as 2D. 2 times 2 times diameter of the, okay. Then after the cut, you install the doubler. Okay. A doubler, a doubler. So you extend it. Okay. Install doubler. So we use back the same. For this doubler, reverts for very fast tenderness. Use similar words as to install angle. But need to choose extra time due to additional thickness from doubler. Okay. However, you must remember there is the doubler is extend up. So we have the original we saw doubler. It's not just here. Here is what we have said earlier. We also need to attach this to the vertical flange. But the one that carry load, normally the one that carry load is this one. This one carry the load. Okay. Carry. For this one, this one is to stabilize the doubler on the angle. So if we look at this issue, we have problem. This is design that you need to check. This, what we are doing here is design. Sorry. So here we are talking about design. Design. So this all here is, we call it design. Design of pair. Similarly, when you have the skin, so we have skin, sectional skin, we have damage, and then you cut off the area. We get the damage here, and then we cut off the area. Okay. For this cutoff, it's no reference. Earlier we used the rivets as reference. For this, the cutoff is you have to cut that you remove the tips of the crack or puncture. Okay, you cut right to that point. So the tips and the crack or the puncture. After you cut, you put the doubler. Put the doubler, and then you put a fastener. Say you put 2 typically. Okay, that is a reverse. Okay. Then obviously we put doubler over. Okay. If this is flush repair, you have a filler. Okay, you cut. This is flush repair. We have a cut. We have a filler to fill up the area that you cut. then you also install fastener. Okay, reverts, reverts, reverts. Okay, we have calculated the load loss. Again, for both L and skin, you need to repair. Repair is restore. Restore what? Restore strength capability to carry the load. So, in order to restore, you must know to restore you must know what has lost. We did that. I hope you understand that. Anyone having problem to understand to calculate the load loss?
No problem.
No problem, okay? So that also an assignment, that also will be in the midterm, that also will be in the quiz, that also will be in the final. Because it's the first thing you need to do. Okay, now we leave it to it. We have done it. The next thing is you have designed this repair. The next thing after you design the repair, you have to do analysis. You analyze the failure mode, what the failure mode can be. Similarly, the skin or the angle, same failure problem. It may be cracked through here, through the hole. So if we crack through the crack on the doubler along the fastener hole, along the rivets. So we call this as net tension failure. So it will be cracked through the rivets hole. So we call this as net tension failure. So here to calculate whether there is a failure or not. How to determine? So the stress on the cross section less than the material stress. Like I say again, material stress is material strength. Okay, which material stress is the material strength. So you load the material, what stress that you get, and you compare. So how to do that? We have to calculate, you know already, we have load loss. We calculate all while we have load loss P. The load loss will be the load that you recover later on by the doubler. You divide by area. Okay, load loss divided by area. Area of between here. Okay, 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 area. Because we have 1, because we have fastener 1, 2, 3, 4, 5, 6, 7. 7 fastener. So the area will be, you have to calculate the area. From here to here is 2D. From this fastener to this fastener is 2D. So 2 times diameter times the thickness times 2 plus, because we have one area here, one 2D here, one 2D here. So plus each fastener you say you put spacing 4D. Okay, 4D time thickness. So how many 4D? 7 fastener we have. We have 1, 2, 3, 4, 5, 6. Okay, we have 6 4D, and then you time by 6. Okay. So this is the area. Okay, area. And then what do you get from here? We got stress, net tension. Anyone having difficulty?
No, sir.
Okay, the stress. You compare the stress with the material. And this stress compare with the strain. Okay, okay, that's first. Second, what you need to do, you need to do shear out. Shear out failure. Shear out failure means when you have the rivets, this is the edge of the doubler. We have rivets. The problem can happen is this area, the river will migrate through this area, and puncture the whole thing. So this area, this phenomena, we call it shear out. Okay. Let's shear out. If you not, you have problem, just refer to the PDF document that I've sent to you, and you also can use the manual to get more understanding. So what will be the what we need to do? Again, we do similar thing. We need to determine the stress. But this is shear stress because it's shear out, shearing off, cutting off that area. So you have to have the force, same, load loss. Load loss divided by how many rivets? Okay, because there is each rivet's load. So we consider the individual rivets load, how much this rivet reacted to this area. So that's why load loss divided number of rivets, how much each rivet get, divided by area. The area will be okay, 2 times diameter. So 2 times diameter is here, the length here. Okay, time thickness. Thickness of this plate divide by 2, which is we have 1, we have 2. So time 2. We got 2, not divide time, sorry. 2. There you get the shear. And again, for this shear, you compare with the shear strength of the material. Any questions so far?
Tak ada, sir.
Tak ada. Okay. Next is the inter-rivet shear. Inter-rivet shear is the failure between rivets. We have rivets. We have rivets. Okay, the rivet trying to migrate across through this region, damaging it. So for this similar, you need to look for the shear stress, load loss, divide by number of rivets to get load for each rivet, divide by area. Area this time is, if you choose 4 times diameter, which is this length here, okay, time the thickness of the plate, you got the area. And we got 2, 1, 2 area, so time 2. So you got the shear stress between the two rivets. Question so far?
So far, okay, sir.
So far, okay, right. So you can score your assignments. Okay, what is next? Anyone having problem with the teams? Someone said his team is lagging. Anyone having the same problem?
Sometimes, sir.
Sometimes. You and Miat or you are outside Miat? The one that having problem.
Outside of me.
Okay. All right. Anyway, everything is why I wrote the book, so you can go refer it. Everything's in there. Now next one is we look at the bearing failure. Okay, bearing failure for the fastener. Okay, we have the fastener. Okay, it tend to fastener is in the hole, rivets is in the hole. It try to squash. Okay, squash this area here. So this area become squash. Okay, squash. Okay, the failure causes elongation of the rivets hole. So how we do that? We have to look for the stress bearing. Okay, FB bearing U. Okay. Sorry. Sometimes we use F is a stress, P is a force. Okay, F bearing BR U U. Okay, FBR first, not U. Equal still loss over number of rivets for you to get the force for each rivets, because now we studying for each rivets. Divide by area. So this area will be as simple as the diameter. Diameter of the rivets time thickness. So this is bearing area. Then compare with the value, this is bearing stress. Okay. Bearing strength of the value. Okay. Question so far? So what else could be the potential failure? Okay, the potential failure could be is buckling. Inter-rivet buckling. So all this from your mechanics material. Inter-rivet buckling. and possibly crippling. Okay, what can happen is we have rivets, we have plate, doubler, so end up here just section of it. We install rivets, okay, we install rivets. So this area may become crumble. So this is crippling. So if we have the same, what we have, and this tend to bulge out. Okay. This one is inter-rivet buckling. So how to calculate the buckling? You have to calculate the buckling. I think you already learned it in the mechanics material. Critical load for buckling is equal pi modulus of elasticity E of the material with time the moment of inertia divided by the effective length square. So the effective length is this length here, this dimension. The effective length is the rivet pitch, which is either you choose either 4D or to 6D. That's why when you install the rivet, you cannot be too long. The distance is too much. You should stay within 4 to 6D to be safe. If you have more than 6, you may have this inter-rivet buckling. However, we need to check for that. So inter-rivet buckling, the L here is the column. Okay, we have few type of column. Maybe you have column of pin joint and pin joint. This L effective equal to L. If you may have open column like cantilever beam, so the effective length here is equal to 2 times the length. The length is between here to here, the actual length. Okay, if both are rigid, fixed, fixed, we have column is also rigid. The length effective will be 0.5, half of the length. So we have the last one, if we have pin and column. Okay, pin and column, so the length effective will be 0.7 length. So in this situation, we have both fixed. Okay, because all riveted, they are both fixed. Both fixed, which is now pi E I equal L over is half of L. Effective will be half of the L. Half Okay, half of, if we choose 4D, half of the 4D. Okay, and this load is a load loss. You compare with the load loss which divide by reverts, number of reverts. So the load loss by the reverts compared to this, if this is lower, then it's acceptable. If it's too high, mean it's already is if too high is okay, sorry, it's reverse. If it is too high, this is load critical to buckle. So if the number is high, mean it's difficult to buckle. So if high is good, if low, then you have problem because the load loss of say 100 for each revert, which is the load acting on that, and then your P creak is 50, then at 50 it will buckle. So it's not good because your load is 100 in the area and then you buckle at 50, mean there is a failure. Questions?
This case kan sama apa dengan crack between rivet?
This one P creak is the load tend to buckle the doubler between rivet. The previous one is try to cut off, to shear off. Okay, this one to shear off, to cut off here. There's a shear. Okay, this revert will migrate through here and go to the next hole. So what you can see, you can have the piece crack. Here, for this issue, you can see between revert, the plate, the doubler will be bulging out. They call it buckle. Okay, if you have flat plate, and suddenly the flat become bulging out. Okay, this phenomena we call it buckle. Okay. If you have plate, suddenly you see the plate become cripple. So this is crippling. Crippling is local failure. Okay, buckling is a global failure because you're looking at the whole plate. Here only section of the plate. Is it clear? Anyone have problem to understand this?
So, jadinya bila dalam kita buat analisis, kalau kita just found one failure, maksud dia macam shear kan, shear between rivets. Maksud kita buat just calculate on that lah, yang lain tu tak payah calculate lah.
Oh, you have to do all these 5.
Oh, alright sir.
So this is the checking. So what I'm showing you is the checking required for every repair that you did, design. Because here, the one that you see earlier, that is design. See? Design, this is what ideally it should be. From your knowledge, from your understanding, from the reference in the manual, that is the repair concept, or that is how the damage to be repaired. However, it's your responsibility to ensure whether this repair is good or not. For example, you design an aircraft. You draw nice, nice looking aircraft. You also put the engine specification with all the performance required. It's not acceptable until you build the aircraft and you test them. Okay, for this repair, if it is really critical, you have to make the test piece and test them. However, for the current requirement, when you go through when you design the repair according to the manuals, it's just sufficient for you to do the analysis. What is I've been telling you here, 4-5 step analysis. If you can satisfy those analysis, the repair is good. You don't have to go for making the test piece and test them. For some area which the analysis is not clear, is vague, and you are not sure you will get the result, and some organizations, for some cases, they make a small test piece. This repair exactly of what they want to install on the aircraft, then they do the testing. That is very safe. Testing is very safe. The best way is testing, but it's very costly in time also. You don't have that time. So you've been hired by a airline to fix the aircraft, which is within the scope. What is the scope? The scope of the repair or the damage is in the manual, and the repair concept is in the manual. If you see the A320 manual, you see about 11 concept repair. If you are able to repair within those concepts, then it is acceptable. If not, then it's not acceptable because you are going to use a different concept. That new concept is not approved by OEM. OEM will not allow you to do it. Clear now?
Yes, sir. Thank you.
You can go back to the manual and you can go to the repair design guideline. It has explained to you all these tests, all this checking, the one that I've been doing, showing you, those has been stated in the repair design guideline of the A320 manual. And for other aircraft as well, it may not have that clear requirement or clear information in their manual. However, for other aircraft like Boeing, you have to go for Boeing repair course. During that Boeing repair course, they will tell you all this information. Happen to be Airbus is generous, they put everything in the manual so we can track their principle in analyzing the repair using the manual. Even though they are very brief, if you go through those requirement, the concept repair, in example 1 to 11 is very brief. If you try to follow it, sometimes I think you get lost. So that's why I re-explain it, but you can go back and refer to those as further if you want to try and further check the analysis. Okay, any problem? So now, looking at what we have done, you are able to determine the defect, you're able to repair the defect, especially for air and skin, from the concept design to the analysis in general. So by now you are able to complete your assignment, do your assignments. So the next few weeks I will continue in how to get this repair done, how to write the information, how to write the instruction to embody the repair, and how to do the inspection if required, how to determine the life of the repair and what further inspection required. At the same time, I will keep repeating this how to do the analysis. If you have problem, I will repeat again, and I hope I can also review from time to time so you'll be able to complete your assignment with a good understanding of the subject. Okay.
Question. Waktu yang first ajak pasal load loss tu kan, kita tak tolak dengan rivet diameter, tapi dalam manual dia tolak dengan rivet diameter. Dia so perlu ke tak?
Dia ada dua. Like I said again, kalau you tengok balik kat sini. Okay, for the load loss, dalam case ni tolak because it has already rivets kat sini. Because the rivet is used to install the angle to the skin. Okay, that's why dia tolak. And for the doubler pun tolak because you cut the doubler. So whole tu dah tak kira. So saya overlook on that one. Tapi saya tak nak make it very complicated masa tu. That's why saya tak tolak. Tapi yes, kena tolak. Kalau tak tolak salah. Very good questions and very good
Yes,
understanding of. Siapa nama you?
Nama saya Nur Siti Aisyah, sir.
No, Siti Aisyah. You saya banyak tanya soalan. Okay, bagus. Okay, good. You minat nak jadi aircraft structure repair engineer?
Minat.
Okay. Minat, okay. Okay, kalau minat, siapa-siapa, saya tak boleh paksa semua. Siapa yang berminat, assignment yang you buat tu nanti, you really do it in good, do it nicely, okay? Do it nicely. You can keep those as a folio. A folio, you print it nicely when you go for interview. So with your CV, you put it to the side of the CV. Okay, especially when you are looking for technical service engineer position where it aligns. Or you're looking for design engineer position, structure design engineer position with any design company. You put it aside, even though they don't want to, if they don't ask for it, just put aside to attract the attention of the interviewer. So at least it can flip through, and at least they will know that you have gone through this course and you have gone through this exercise, which is real. Everything's from the SRM, and I also show you how to read the SRM, mainly on 320. However, the Boeing does not have the repair design guideline, but all the chart, material strength, rivets, everything, they have the same thing in the Boeing manual. To choose the value L, LT, A, and B, those chart that you see in the 320 also in the Boeing manual. Only the Boeing manual does not provide those concept repair, the 11 example that you see in the design repair guideline. For that design repair guideline, if you work on Airbus, any Airbus aircraft, it will have that chapter. If you work for 320, 330, 340, 380, they will have the same chapter. They copy those chapters to all the Airbus manual, Airbus type, including A400M. If you happen to be later on be employed by the Air Force and been tasked to work with 400M, the same pages of repair design guideline appear in the A400M manuals. Okay, so what I'm giving you is what is out there. So if you follow, hopefully you will be landed a job as a technical service engineer structure with the alliance, the air forces, or any organization that doing repair on aircraft structure, repair and modifications. Okay, and also you have also videos. I ask you to do the video presentation. If you're really looking for the job again, you can do it. You can do the video nicely. You also can send those to your potential employer of your video presentation. That also will attract them. Okay, clear?
Yes, sir.
Any question? Any question? Can I stop here? Okay, I will stop here. You continue. I think you have many things toward the end of the semester. If you have time, about 1.5 hours, then the time used wisely to start working on the assignments. For the quizzes, I will look at the score. Anyone not miss the score, I will ask you to do again. And for the midterm,